Today, I will be discussing two important gas laws and I will be demonstrating how to use them. Each gas law has a mixture of pressure, volume, temperature, or all three. An important vocabulary word to use for this is gas laws, the physical laws that describe the properties of gases. I will be focusing on the gas laws of Boyle and Charles. They can be found in chapter 14.2 in the textbook. One of the most amazing things about gases is that, despite wide differences in chemical properties, all the gas laws more or less obey the gas laws. The gas laws deal with how gases behave with respect to pressure, volume, temperature, and amount. Gases are the only state of matter that can be compressed very tightly or expanded to fill a very large space. Pressure is force per unit area. It is calculated by dividing the force by the area on which the force acts. The Earth's gravity acts on air molecules to create a force. This is called atmospheric pressure. Units of pressure include the Pascal, abbreviated PA, standard atmosphere, abbreviated ATM, and torr. 1 ATM is average at sea level. It is normally used as a standard unit of pressure. The SI unit is the Pascal. 101,325 pascals is equivalent to 1 ATM, but a much more convenient unit is the torr. 760 torr is equal to 1 ATM. A torr is the same unit as the mmHg. Boyle's law. It is the pressure-volume law. If the temperature is constant, as the pressure of a gas increases, the volume decreases. Boyle's law states that for a given mass of gas at constant temperature, the volume of the gas varies inversely with pressure. When pressure goes up, volume goes down. When volume goes up, pressure goes down. The equation that will be used is P1V1 equals P2V2. Using Boyle's law, as stated before, we will use P1V1 equals P2V2. A balloon contains 30 liters of helium gas at 103 kPa. What is the volume of the helium when the balloon rises to an altitude of which pressure is 25 kPa? We have our known pressures here, 103 kPa and 25 kPa, and our first known volume, which is 30 liters. So, to start off, we'll write the equation, and we'll plug in our known numbers. So the first pressure is 103. The first volume is 30. The second pressure is 25, and we're solving for the unknown volume. So to start off, we're going to multiply 103 times 30. That gives us 3,090 equals 25 times the volume. So now you want to divide 25 on both sides. And that will give us a volume of 123.6. The second equation. A 1 liter of gas at constant temperature has a pressure of 2 atm. What will the pressure be when increased to 30 liters? So our first pressure known is 2 atm. We're solving for the second pressure. The first volume is 1.0 liters, and the second is 3.0 liters. Start with the equation, plug in our knowns, so that'd be 2 atm times the first volume, which is 1, is equal to P2 times 3. Like before, we'll multiply 2 times 1, which is just 2. That's equal to a pressure times 3. Now we divide 3 on both sides. And in decimal form, P2 will equal 0.66 with a bar. Now let's move on to Charles' law. Charles' law is the temperature-volume law. As the temperature of an enclosed gas increases, the volume increases, if the pressure is constant. Charles' law states that the volume of a fixed mass of gas is directly proportional to its Kelvin temperature if the pressure is kept constant. The equation we'll be using is V1 over T1 equals V2 over T2. Now we will try out some problems. As stated before, we will use V1 over T1 equals V2 over T2. Our first example states, a balloon inflated in a room at 25 degrees Celsius has a volume of 4 liters. The balloon is then heated to 58 degrees Celsius. What is the new volume if pressure remains constant? So we'll list our knowns. Our first volume is 4 liters. We're solving for the second volume. Our first temperature is 24 degrees. And our second one is 58 degrees. So let's write down the equation. And let's plug in our knowns. That'd be 4 over 24 degrees Celsius equals V2 over 58. Now we cross multiply. So we do 58 times 4. That equals 232 to 24 degrees Celsius times V2. Now we divide 24 on both sides. And our second volume will be equal to 9.6. Our second example states, a perfectly elastic balloon contains 6.75 liters of air at a temperature of 40 degrees Celsius. What is the Celsius temperature if the balloon has a volume of 5.03 liters? So we'll list our knowns. Our first volume is 6.75 liters. Our second volume is 5.03 liters. And our first temperature is 40 degrees Celsius. We will be solving for the second temperature. So, let's write down our equation. And let's fill in our knowns. So V1 is 6.75 over the first temperature, which is 40 degrees, is equal to 5.03 liters over our second temperature. Again, let's cross multiply. 40 times 5.03. That will give us 201.2 is equal to 6.75 times T2. Now let's divide 6.75 on both sides. And that gives us 29.8, and that can be rounded to 30 degrees Celsius. So for both of these problems, you may have to round, or you may have to convert liters to milliliters.